Hi everyone. Today we are going to discuss about fundamentals and link layer in computer networks. And this we have building a network and requirements for our first topic. Okay. First of all, what is network? Why do we need computer networks here? What's the use of computer networks? Okay. First, why do we need networks?
Networking is the word people use when they're talking about connecting computers together so they can share data with each other and all connect to the internet at the same time. Let's take a closer look at the key components that make up a simple, easy to set up network. Think of a network as something similar to your body's central nervous system. At the top of the network is a brain that handles all the traffic coming through. This is called a router. The brain is connected to a spine that sends signals throughout your network. This device is called a switch, and it distributes signals to all of your computers and devices via network cables. Now let's check out each of the components of a wired network in more detail. We'll start with the router. A router has a smart little computer inside that identifies all of the computers and devices on your network and assigns a unique number to each one. Techie people call this an IP address. A router also connects to the internet outside your home via a modem that can be provided by your DSL or cable internet provider. A router is always at work, managing the tons and tons of information your computers and devices send and receive, and controlling which computers and devices get what information and when. So how does a router actually send information from the internet to your computers and devices? And how does it enable your computers to share information with each other? The answer lies with that device we mentioned earlier, a switch. A switch sends traffic through your network to the places it needs to go. Every Netgear home router has a switch with 4 ports built right into it. You can also get wireless routers from Netgear that use radio signals to do the same thing as a switch. But these still have those 4 ports built into them, so you can use wires with them too. When you're buying a router for use in a wired network, pay attention to the speed of the built-in switch. The fastest switches are called gigabit, and they're perfect for applications like streaming video in your home. Meanwhile, routers with switches called fast Ethernet are great for essential tasks like web surfing, email, and online gaming. Now say you have more than 4 items you'd like to plug into a router. You need more ports. The solution is easy. You'll need an additional switch, which again is that thing that's already built into your router. In this case, though, you just need the switch portion and not another router, because your network doesn't need 2 brains after all. Netgear has switches with as few as 5 ports, as well as some that feature 24 ports or more. Once again, if you need the fastest speeds, go for a gigabit switch. Your SmartyPants Netgear router will recognize these new connections and start sending data to them right away. Here's one more thing to keep in mind. Some people often confuse a switch with a related device called a hub, which is obsolete. You just need to know that hubs were replaced by switches because switches do the same thing, but with a lot more speed and smarts. A router, a switch, and network cables all come together to create a fast and reliable wired network that works a lot like your body's nervous system. Fortunately, you don't have to be super brainy to understand how it all works.
Basically, we have building a network and requirements. Okay, what is computer network? We know that a group of computers are connected together for sending and receiving the data. To whom they are sending and receiving the data? Yeah, to make some applications like email, video conferencing, like TV or any channel broadcasting, like that we have. Okay. Is there any particular terminologies used in computer networks? Is there any particular components used for that transmission of data? Yeah, we have mainly 3 components. The first one is node. What is node? We know that the computers are electron devices that are connected to the network that represent everything. It is called node. Okay, what is host? It is just a general purpose computer. Okay, how do we initiate the connection? How do we identify that it is a sender, it is a receiver? How do we identify that? Yeah, with the help of some addresses like people's address, like that only we have it in computer networks also. Okay, we have internet protocols for IP address. For example, 192.168.15.250, like that. It is a unique address to identify a computer in a quick minute, whether it is a sender or receiver, like that we have IP addresses. Okay, first of all, we are going to identify building a network and why do we build a network here. First one is to understand what is a computer network, how to build a scalable network, and understand a computer network architecture and what are the components presented in the computer networks and where it is used in the real time. Okay, first of all, we are going to discuss some applications of computer networks. Okay, first application is www, that is World Wide Web. We are browsing some kind of information in World Wide Web. And second one is email, online social network, streaming audio and video, file sharing, instant messaging, information gathering, like that we are having. Okay, in class of application we have two types. First one is only text and image, and also we have both audio and video. Okay, how do we send or how do we receive the data? Is there any rules? Is there any rules and regulations followed in computer networks? Yeah, it has some rules. A set of rules and regulations to be followed in the transmission of data in some kind of applications or all the kind of applications. We have protocols. Protocols is just a set of rules that are used in computer applications. It may be varied depending upon the application status. Okay, here we have some type of application protocols. First one is URL, the second one is HTTP, and third one is TCP, and the fourth one is IP, that is Internet Protocol. URL is Uniform Resource Allocator, and HTTP is Hypertext Transfer Protocol, and TCP is Transmission Control Protocol. It controls the transmission to the overall network connectivity. And the last one is IP, Internet Protocol. Okay, we need 17 messages for one URL request. Here 6 messages to find the IP address, 3 messages for connection establishment of TCP, and 4 messages for HTTP request and acknowledgement, and 4 messages for train down TCP connection. Okay, in the next class we are going to discuss the what is TCP, what is UDP, why do we need TCP and UDP, what's the role of TCP in real time, also what's the role of UDP in the real time. Okay, today is just an overview session, so we just discuss about what is TCP, what is UDP, what are the applications of computer networks, that's it. Okay, okay, what are the requirements of computer networks? In requirement perspective, we have application programmer, network designer, and network provider or network operator. Okay, first one is application programmer. Okay, what's the purpose of this application programmer? Here list the services that is his application needs. He lists some of the applications, or he lists the applications what the customer need. He satisfies the customer needs, basically that is the concept. Okay, for example, a guarantee that each message the application send will be delivered without error within a certain amount of time. It is a requirement of any particular customer to the application programmer end. Okay, the second one is network designer. What's the role of this network designer? Yeah, same thing, to design a cost effective network with shareable resource, that is everyone needs. Okay, for example, the network resources are effectively utilized and fairly allocated to different users, because we don't want a particular resource used only for a particular application, because it consumes high cost, and also we need a lot of resources for different kind of applications. So we need the network resources are should be utilized effectively and it should be fairly allocated to different types of users. Okay. Next one is, what's the role of network provider or operator? List the characteristics of a system that is easy to manage. The system should be easy and should be manageable. For example, suppose if any fault located in the computer network, it can be easily isolated and it can be configured correctly at the particular time. Okay, it should not consume a lot and it should not disturb the connectivity, or it should not interpret, or it should not give some misconveniences to the customer end. That's the main motto. Okay. And we know that to build a network, the scalable connectivity is very important. For example, the network must provide connectivity among a set of computers. It should give a more number of connections to a set of computers. That's the main thing. Okay. Second one, sometimes it is enough to build a limited network that connect only a few selected machines because of privacy or security. Sometimes we need it. And a system that is designed to support growth to a large size, it should be scalable. We know that. For example, internet. We can add more number of computers for a particular time using internet. At the same time, we can restrict the number of connections because of security and privacy support. Okay, so the system should be scalable for better connectivity or better efficiency. Okay, and what are the terminologies used in computer networks? In this we have mainly a link. What is a link? For example, we have coaxial cable and optical fibers for wired connections that are called as link. Okay. In wireless, we don't have any wired link. The transmission is only through air media. That's it. Okay. In wired networks, we are using physical connectivity like coaxial cable, optical fibers, and in wireless we don't need any physical connectivity. Okay. What is a circuit switch? It is mainly used for telephone system. In this we have packet switching also. It has higher efficiency and it mainly used in computer networks. Okay. What is inter-network or internet? Yeah, we know that a set of computers can be directly connected. A set of independent networks or clouds are interconnected to form an inter-network or internet. Okay. What is a router? Yeah, a node that is connected to two or more networks is commonly called as router or gateway. The main functionality of router is forward message from one network to another network. Okay, what is host-to-host connectivity? Yeah, we know that the host-to-host connectivity is done by assigning address to each node. That is for sender address and receiver address. Previously we discussed about IP addresses. Same thing. We have different IP addresses for sender as well as a receiver. Okay. Routing. Okay. And this we have in addressing we have three types. The first one is unicast, second one is broadcast, and third one is multicast. Okay. What is unicast? The source node wants to send a single destination node, then it is broadcast. Okay. The source node wants to send a single destination node, then broadcast. That is called unicast. And broadcast, the source node want to broadcast the message to all the nodes in the network. To all the nodes in the network, it is called as broadcast. And multicast. Okay, the source node wants to tell a message to some set of other nodes, but not all of them. That is called multicast. Unicast is to send a single destination node. That is called unicast. And broadcast to message to all, that is called broadcast. And multicast send message to a particular set of users, that is called multicast. Okay, and also we are using multiplexing in computer networks. Okay, in this we have two types. First one is STDM, that is synchronous time division multiplexing, and frequency division multiplexing. Okay. And synchronous time division multiplexing, the time slot is divided based upon the users or based upon the applications. And frequency division multiplexing, the frequency, the set of frequency is divided based upon the number of users or based upon the applications. Okay. Next one is quality of service. A network that attempts to locate bandwidth to a particular floor, it is said to be quality of services. Okay. Congestion. Okay. Normally we use the term congestion. Okay. First, what is congestion in network? Same thing, when a switch run out of memory for a packet storage, there will be a chance some packets will have to be dropped. When a switch is operating in this state, it is said to be congestion. Yeah. And also we have network types, LAN, MAN, WAN, SAN, we know that. Less than 1 kilometer is called as LAN, less than 10 kilometer MAN, WAN is geographically distant computer, and SAN is single room computer with various computers. Okay. Okay, support, we know that computer networks are give a huge support for common services. Okay. A lot of complicated things must be happen beyond sending messages from one host to another. Many applications need common services, so we need to implement those common services to one. Okay. In this we have channel. Channel is like a pipe connecting two applications, so we can send data at one end and receive the data to another end. Okay. Okay, what's the use of channel in computer networks? Connecting one process to the another in an application level, that is called channel. Okay. In this, we are going to identify some common communication factors like client and server. A process that requires access to the file, that is called client, and process that supports access to the file, it is called server. Okay. And this we have different types of channels. The first one is a request reply channel and message stream channel. Okay. In request reply channel, it is mainly used for file transfer, and it is used for PPI, that is protect privacy and integrity of data. And unauthorized party cannot access because it is a request reply channel, and every message sent by one side, it is received by other side. Only one copy of each message is delivered. It should not go with any uninterpreted service. It should not go with any interpret services unoperable conditions. Okay. It should not move to the unoperable state also. So we use a request reply channel. Okay. And we have a message stream channel. This channel used by both video on demand and video conferencing. Normally we are using in this pandemic situation. Okay. And what are the difficulties? What are the difficulties while we are going for a channel? First one is ensuring messages delivered or not. It is a difficulty. And receive the messages in the same order or not. We don't know whether this order from the sender is correct or incorrect. We don't know about that. And ensure no third party in the channel. We don't know actually who is interrupting the service, who is getting the data, who is an intruder in that particular connection. We don't know that. Okay. In reliability, we have some failures: machine, fiber cut, electrical, some electrical and mechanical inferences, and the switch time run out, or buffer space is not enough for communication. Like that, we have some failures in reliability. Okay. To avoid this error, we have to find out some manageable techniques to improve our efficiency. Okay. In this, we have some types of errors like a bit error, single bit error, burst error, packet failure, node and link failure, power failure, system crash, physical link is cut, like that. So we have to identify which error losses our connectivity, and also we have to ensure our network should be operable, and it should be cost effective, and it should not affect any data while we are using this parallel communication. So So we have to reduce our network's traffic. Also, we have to identify what are all the easy methodologies and what are all the and what are all the effective communication methodologies to enhance our network security. Also, we have to enrich our system connectivity also. So, also thank you.